Okay, hello everyone. Now we have all the talks done by the speaker. Let's look at the numbers. Okay, we have already over 600 audience online. So this is really hot. Thank you all the speakers for your great work and for your great sharing. Okay, let's move on. Let's move to the final, the next, and also more exciting section. That is our panel discussion. So let's discuss the future application and technology development of zero-knowledge proof with our guests. Now, let me introduce our host of the panel session, Wish Longer, who is the co-founder of Ferrous, a EVM-compatible deep parallel layer 1 network. We also have the speakers from Xiu Sang from Zen, who is the product manager. We also have Ming, our old friend, who is the CTO of Zero Gravity, who is the data and AI for Web3. And we are also very happy to have Cecilia, who is from Tyco. And the last guest is Wesley Wei Changjeng, who is the principal researcher of AntChain OpenLabs and who is leading all the ZKP efforts of AntChain OpenLabs. Now, let me pass the time to Wish Longer.
Hey, thank you, Ian. Thank you for the introduction. It's a great honor to host the panel. As I'm Wish Longer from Ferrous, and also welcome all the panelists here today. Yeah, so let's begin. So over the past 2 hours, I think we've heard many true in-depth and technical discussions about the ZK. So let's shift it to something a bit easier to digest in this panel. So yeah, so at the beginning, I think I want everyone to say hello. Our panelists say hello from the online. So Ming Wu, the CTO from Zero Gravity, could you say hi to the audience?
Hello, hey, here is Ming, and yeah, it's my pleasure to join this exciting panel discussion. And Zero G is a system that's trying to provide a really scalable, decentralized infrastructure for the entire AI pipeline, which includes the scalable storage solution and also the computation stuff for the AI inference and also for the model training. Yeah, so there's a bunch of ZK technologies actually used in this system, and yeah, looking forward to the further discussion.
Yeah, thank you, Ming. And also Cecilia from Tyco.
Hi, everyone. My name is Cecilia, and I was a ZK engineer in Tyco. Now I'm a blockchain engineer. Tyco is a base rollup that focused on base sequencing, and we're also a theoretically ZK rollup, but we're currently using TEE. And we shifted our focus to like synchronous composability and block building and all the different infrastructure in the base ecosystem. Thanks for the host for introduction, and I'm looking forward to the discussion later on.
Yeah, thank you, Cecilia. And also we have Xiu Sang, the product manager of Zen.
Hi, nice to meet you. I'm Shuson. I'm the product manager from Zen team. Yeah, as we all know, Zen is a new Web3 brand from Ant Digital Technologies, and it's powered by AntChain OpenLabs. So I'm the productor who's responsible for PowerZero. Yes, PowerZero is zero-knowledge acceleration solutions. So we can provide ZK-friendly GPU servers and maybe a lot of solutions such as FPGA IPs and GPU libraries. Yeah, and today is really happy to attend the panel. Yeah, thank you.
Yeah, thank you. And also, finally, we have Wesley from the AntChain OpenLabs.
Hi, everyone. I'm Wesley from AntChain OpenLabs, the principal researcher. AntChain OpenLabs worked on ZKP and computational computing over past years. So it's very pleasure to join this panel and looking forward to have a a nice discussion. Thank you.
Yeah, okay. So welcome everyone again. So I have a few questions for this panel. So as the beginning, so I think most of us have joined the token 2049 recently, and were there are any notable trends or innovation approaches to the ZKs that stood out to you at the event? I hope everyone could share some insight about that. Yeah. So yeah, anyone could just unmute to answer the questions. Yeah, me, could you come first?
Sure. So, yeah, so I'm excited about the future of zero knowledge technology, and ZK Tech is set to revolutionize the multiple aspects of the digital world. So particularly in the blockchain and beyond, and we are looking at significant advancements in several key areas. So scalability is a major focus. I think ZK rollups are evolving rapidly, promising to dramatically increase the transaction throughput while keeping costs low. So this could be a game changer for the blockchain adoption. Secondly, the privacy and the data protection will see substantial improvements. Advanced ZKPs like ZK-SNARKs are continuously evolving, offering stronger privacy guarantees. This isn't just for crypto, and we are talking about potential applications in finance, healthcare, and supply chain management. The technology is becoming more accessible too. So we are seeing efforts to simplify ZKP implementation and reduce the computational requirements. This should lead to a broader adoption and more innovative applications. Integration with other cutting-edge tech like AI and IoT is on the horizon, and this could open up entirely new use cases we haven't even thought of yet. And also, besides the optimizations on the ZK technology algorithm itself, I also see another angle that from application side, we can actually make the application more amenable to the ZK computation format. For example, for the ZK ML, and because this sparsity and also the quantization of the ML algorithm have heavily deployed. So there are some existing researches that use this quantized and sparse networks to make it more appropriate for the ZK computation. Someone used a ternary network which only contains the value of -1, 0, and 1, which actually quite simplify this the kind of eliminates the necessary multiplication of the cryptographic computation, and it works well by combining with this GKR based solution. Yeah, it's very promising. So overall, the future of the ZK technology looks bright. It has the potential to enhance the privacy, scalability, and the security across various industries. As we continue to push the boundaries of what's possible with ZKPs, and we are likely to see the transformative applications that reshape our digital landscape. So it's a very exciting time to be in this field. Yeah.
Yeah. Thank you for your share. And also, Cecilia, do you have anything to share?
I didn't go to the token 2049, but I did saw its progress on Twitter a lot. Unfortunately, there isn't any discussion about ZK that I saw, but I do see that like the standard discussion focus on like Ethereum core protocol design, like how should we bring ourselves one step closer to the Ethereum endgame. Also, like the Solana Breakpoint conference was also very popular. That I see like the intersection between like the Ethereum developer and Solana developer, where like people from two ecosystems are trying to learn from each other, and to see like how do we approach like things that related to ZK is, for example, like should we do like single slot finality? Should we do proofs, real-time proofs, like Justin Drake said? Yeah, so regarding general progress of ZK, I do feel like This year, since like the tool chain has matured so much from the development of SP1 and RISC-0, the paradigm at which people develop ZK application also consolidate and further modularize. Like ZK in a blockchain application level is being used to prove, state transition of some logic regarding some publicly visible on-chain data. And how do we get that data, and how do we access that data? How do we read? How do we prove? Now it's like a standard playbook. For example, you read stuff on chain and you run your actual logic in SP1 or RISC-0, and also the same Rust code can be also proved with TAE. That's what we call multi-proof. I mean, like, as long as these interface, these pipeline are mature, people can swap out the actual proof here and there. So, and that really motivates like general developer to integrate ZK solution in their stack or in their application. And that also creates more demand for proof, which initiated the development of Proverse market. So I don't think I'm in a position to comment on like the ZK mathematical core protocol design, folding, and all that stuff, or ZK acceleration. But I do think that those stuff come later. And the premise of these are the maturity of ZK application themselves. And I'm seeing a lot of progress in that end. Yeah, so that's my take.
Yeah, interesting. From the toolchain side for the to the development of the ZK technology. So how about Xiu-san? So you're a product guy. So how do you say is there any interesting product you have seen recently?
What a pity. I think there is nothing interesting. Yes, I attended Token 2049 and last week, and I noticed that the ZK technologies is currently mainly still focused on maybe ZK rollups to address mainland performance issues, either for maybe Ethereum and Bitcoin. So that's all.
Okay, cool. And how about Wesley? So you are a researcher of the ZK. Do you see any like
Yeah.
advancement or interesting?
Yeah, at Token 2049, I walk around the exception area and come across a couple of ZK projects like the circuit and Talos. One introduced the AI into their rollup sequencer service, and the other is working on a proof of proof. I think over the past couple of years, there has been a lot of excitement work in ZK infrastructure area, including variants of ZK VMs such as ZK Wasm, RISC-0, SP1, Jot, ZKM, and many ZK rollup services such as Scroll, Tackle, Polygon, and so on. So now I think what we need now is a more vibrant application ecosystem to help to unlock the full potential of this infrastructure. Yeah. So thanks.
Okay. Yeah, thank you for sharing that. And for the next one, so I think for the past few hours, we've heard a lot of the technology about ZK, zero knowledge, and we know that ZK technology has a very steep learning curve, which create a barrier for product and business professionals in grasping its capability. So I heard a lot of complaints that from the users and even the developers that it's hard to understand how ZK is implemented in various projects. So today we have many panelists. We have researchers, we have engineers, we have CTOs, and we have product guys. could you help to provide some of your insight or examples that could help that ordinary people to understand what a ZK is and clarify what they are doing in the application in the industry? Yeah. Also, we start from the CTO, from Min.
Yeah, okay. So, so understanding the applications of ZKP in the industry can be approached through the lens of its core algorithms properties. So the ZKP algorithm offers two key features: the privacy protection and asymmetric computation. The privacy protection feature allows the prover to demonstrate the validity of a statement to the verifier while only revealing the conclusion, concealing all other sensitive information. Notably, the degree of information disclosure is configurable corresponding to the public input in universal ZKP systems. So this flexibility significantly enhances the versatility of ZKP applications. In the financial sector, the privacy features of ZKP have found widespread use, such as in private asset transfers and anonymous identity verification. So the asymmetric computation feature actually enables the offloading of the most verification computational burden to the prover side. So this characteristic aligns perfectly with the blockchain technology, which inherently operates on the compute once, verify many models. And the introduction of ZKP allows a high-performance proof node to handle the majority of transaction validity verification network. So while numerous lightweight nodes perform the minimal and repetitive verification operations without introducing additional trust assumptions. So this mechanism significantly improves blockchain scalability while maintaining the decentralization and security. Currently, various ZK rollup projects leveraging this principle to enhance the blockchain throughput and efficiency. The applications of ZKP technology are rapidly expanding beyond the aforementioned privacy protection and scalability applications. So ZKP is showing immense potential in areas such as secure data sharing, decentralized identity systems, and supply chain traceability. As ZKP algorithms continue to improve in efficiency and hardware performance advances, and we can anticipate that the emergence of more innovative application scenarios. I think it's important to emphasize that while ZKP technology has made significant progress, it still faces challenges in practical applications, such as proof generation time and system complexity. So these remaining areas for ongoing optimizations in current ZKP research and engineering practice. Yeah.
Okay, thank you. How about Cicely? You are from your engineering side. How do you understand the ZK from your perspective?
Well, since your question was asking, you want to let the general audience and like product people, business people to understand ZK, like my genuine suggestion is like, don't even try to understand ZK. I think I think most consumer grade applications should integrate TEE first in their proving solution. If you do want to supply a sound and performance solution to verify your integrity computation, you should definitely do Intel SGX or TAE first and have that running on your stack on your integrated environment, and then port in ZK, right? And by the time where your product manager or your business people understand like the functionality of how TEE works, trusted computation environment, I think that's much easier to understand. By the time that they understand how that works, it's very easy to understand also how ZKP works, right? Because like if you're viewing from a product design standpoint, all you need to do is that ZK verify computation integrity. You don't actually need to know like the nitty-gritty details of the math and also the theory and also like the performance issue. And you also only need to know that like ZK is slightly, not slightly, but much more slower than TE. Like that's everything that you actually need in order to have a viable product design and for your consumer to digest like what the ZK actually do. Sell alongside with the privacy part. I mean, if you do want to also leverage the privacy property of ZK, like that does require some extra education for your audience, right? Because you have to have people trust the fact that ZK actually protects your privacy through mathematical tricks, right? So yeah, but I don't think that having everyone understand everything at a fundamental level is that important at this point, because we've already evolved from oh yeah, what is ZK? Like ZK rolled up with versus optimistic rolled up to an era where consumer product with ZKP start showing up, and like the integration of ZK is the cost of integrating another ZK technology is pretty low. And this is exactly what we're doing at Tyco, right? Like currently, we're testing our ZK proof, our like contestable proof protocol on our test net, but our main net, there's only a TE proof. Like all of the interface are ready, like all of the verification contracts of ZK are already actually deployed, but we aren't actually running any ZK proof because like we're still testing that. And submitting ZK proof does cost a lot of money. Like we do need to pay like SP1 or ZK zero, not was it a risk zero, a lot of money in order to have per block ZK proof. So I do think that TE is a much more viable middle ground solution, and much more easier for average people to understand. So that's my take.
Okay. Yeah. So I saw Kobe also online, and he is the CEO of the Zen. So from the CEO side, how do you think about the ZK, and how do you convey the ZK technology to your users, to your customers? Kobe.
Yeah, thank you. Thank you, Bert. I'm sorry for being late. I think we can learn from the history. So think about the TE and AI. So when does them become really famous for every ordinary people, and why people can, a lot of developers come here to learn about this kind of technology? I think the moment from the iPhone moment that iPhone actually do a face unlock to unlock your phone with your face. And based on that, we know that there'll be some edge computing about the AI, and also there will be people care about the privacy and security on your chip, on your mobile phone chipset. And that's why PE become very famous for ordinary people. And after that, there are a lot of, since there is a race on the demand side, so there will be on the supply side, there will be more and more developers try to learn about how to use this kind of technology. So from my perspective, I think we are still waiting for a kind of iPhone moment for ZK, for ordinary people, that people can learn. More people have this kind of demand, then we need more developers to ZK development. Otherwise, if we have, let's say, 1 million people, developers for ZK, so who will pay them? That's basically the problem. On the other hand, when we talk about on the developer side, so to let ordinary people, that more developers to get familiar with such kind of a ZK proof, they don't need to write everything from scratch. That's pretty much very similar to what we have for the AI side. So people, there are a lot of people to do the lower level, like the code for optimization, to speed it up, to make all the hardware plus software acceleration optimization, but that's not too many people. Even for AI, those kind of people is maybe less than a few hundred in China. But there are more and more developers develop the applications based on the low level optimization. So you have a lot of ASIC chips, and also cloud service, and also cloud SaaS service to help you to speed up, do the optimization. But more and more developers understand how to use this kind of tools that provided by low-level optimization companies then to build their own applications. So that's why Zen start this kind of a product line with Power Zebra. So we provide like an online SaaS service for ZK acceleration for GPUs, and also we have the ASIC and FPGA solutions to get ready for the future ASIC trend. I think all these kind of products that by Zen, also by other companies like Indoyama, we make the barrier lower for developers. But it still come back to my first point. We are still waiting for some demand side iPhone moments for the consumers. Thank you.
Yeah, thank you, Kobe. So because of time, I think we should move to the next question. So the next question is, despite years of discussion around the zero knowledge technology, but we still see mass adoption in Web3 is still feel distant, right? So in your opinion, what stage is the ZK is currently in, and what do you see as the key barrier to its adoption? Is it a matter of the leading of a scalable infrastructure, or it needs a breakthrough in the ZK technology, or it's it needs for the more innovative and practical applications? Yeah. So it's still starting from me.
Okay, so ZKP is at a crucial crossroads right now. So we have moved past the purely theoretical stage and are seeing real world applications, especially in the blockchain space, but we're not quite at the widespread adoption yet. I would call the current stage the early practical implementation. So we're seeing ZK tech deploy in the specific use cases, particularly in the layer 2 scaling solutions for blockchains and some privacy preserving applications. However, these implementations are still mostly confined to niche areas. When it comes to barriers to adoption, it's really a mix of factors. First of all, there are technical challenges. So we have made big strides in the ZK technology, but issues around proving time and the computation resources are still there. So for many applications, the current ZK proofs just too slow or resource intensive for practical use at scale. Then there's infrastructure limitation. The current blockchain infrastructure isn't fully optimized for the ZK applications. So we need more robust, scalable system that can efficiently handle the computational demands of ZK proofs. As mentioned in the last question, the complexity is another big issue. So ZK technology is inherently complex, so making it tough for the developers to implement and for users to understand and trust. The lack of a standardization doesn't help either. So without widely accepted standards for the ZK implementation, so we are seeing hindered interoperability and slower adoption. And also the regulatory uncertainty is also a factor. The privacy features of the ZK technology, while beneficial, raise regulatory concerns, especially in the financial applications. And further, while we can imagine many potential use cases, there's still a gap in developing compelling user-friendly applications that show a clear value over existing solutions. In my view, the path to the mass adoption requires progress on multiple fronts. So we need continued R&D to make ZK proofs faster, more efficient, and easier to implement. The recent developments like Fold, Lookup, and ZKVM are steps in the right direction. Building more scalable and ZK-friendly infrastructure in the Web3 space is crucial too. Developing user-centric applications is also very important, and we need innovative apps that leverage ZK technology to solve real-world problems in a user-friendly way. At the same time, we need to boost education and awareness, increasing the understanding of ZK technologies among developers, users, and regulators. So this is key to building trust and driving adoption. Lastly, establishing the common standards and best practices for the ZK implementations could accelerate adoption and interoperability. All in all, the mass adoption might seem distant. The foundations are being laid. The next few years will likely be critical in determining whether the ZK technology can bridge the gap from the promising technology to practical, widely adopted solution in the Web3 space. Yeah, thank you.
Thank you. Very comprehensive ideas. So how Wesley? You are a researcher on the ZK. So how do you think about the what is stage of the current ZK adoption?
Okay. I think current is a very good time for ZK, though it's too complex and has some barriers, but we can see more and more people involved and more excited projects created. So I think ZK-proof technology has rapidly advanced alongside blockchain, but I think they both play equally crucial roles. They are both addressing trust issues. Blockchain decentralization helps verify transactions, while ZK is particularly effective for verifying complex computations. So together, they create a solid foundation for the trust of the digital world. For instance, we are working on ZK proof system based on a hybrid processor architecture. The goal is to leverage ZK technology for a wider range of computational verifications. We have developed such as ZKML, which supports 10 different machine learning algorithms, and to validate the model prediction and giving user greater confidence in when they are using these algorithms. In this process, the design we designed the basic circuit tailored to the machine learning algorithm and aggregate them using a general purpose virtual machine like ZK-Versa, and that's to adapt to various trace models. And this significantly boosts the proof efficiency. And we apply similar concepts to large language models by leveraging linear layers and carefully designing the nonlinear layers to enable the verifiable inference. I think it may be helpful for providing trusted inference service for applications like the off-chain oracles in future. That's my opinion. Thanks.
Yeah, thank you. So I wanted to Xiu-Sang, how from a product guy's view, how do you think the current the ZK adoption from the ZK applications? Hello.
Sorry. I think sorry. Okay.
Yeah, we can hear you.
Yes. Maybe I believe the zero knowledge proof technology is still in its early but rapidly evolving stages. Because I noticed that there are many ZKP frameworks available, and they are all updated frequently. Currently, the main barrier, that's the question. The barrier to adopting their knowledge proofs is maybe performance, as generating them takes considerable time. So I think breakthroughs in ZK technologies will require more innovation and practical applications. Because I'm a product manager, so I believe that real demand drives the faster iterations. Yeah, that's all.
Okay. Thank you. I think because of the limit of the time, so I think that's all for today. For the panel. Yeah, we thank you again for all the panelists. Yeah, thank you.
Okay, thank
you,
you,
Thanks.
Mr. Longer. Thank you, all the panelists. Okay, time flies, and our second zero knowledge proof workshop is coming to a close. And thank you all the guests for the fantastic sharing. We still have more than 600 people online. So we hope the end of this workshop also marks the beginning of our continued technology exploration, especially in zero knowledge proof technology. And AntChain OpenLabs will always provide a stage for you for every single Web3 innovator. Again, thanks everyone for your participation. And do not forget to follow the Twitter of AntChain OpenLabs, Zen, and Ferros. And see you next time. Thank you. Bye-bye.